Welcome to the CGVR Study Labs thesis preparation video, where we're going to talk about your thesis content by type. First, we're going to learn about the Bloom's cognitive skills taxonomy. So this is a taxonomy of cognitive skills, where in the bottom you have remember, so you know the facts and concepts of something. The second layer is understanding, so you're able to explain the domain to someone else. The third layer is applying, so you are able to apply the knowledge from that domain to solve new problems. For example, if you are solving a quadratic equation, you are now able to solve any quadratic equation regardless of the numbers in the equation. The fourth layer is analyzation, so you are able to relate and compare the aspects in that domain. You're able to really go into the domain and analyze the pros and cons of different approaches or different concepts. The penultimate layer is evaluation, so you are able to justify and assess the value of particular solutions or particular approaches. And the topmost layer is creation, so you're able to make original new solutions. Sometimes in the Bloom's cognitive skills taxonomy, the creation and evaluation are also switched, but in this particular video we're going to follow this order. Now the sections of your thesis, the content of your thesis, actually shows your abilities in each of those levels. Except well remembering, because you are writing your thesis, so it doesn't really show that you personally remember all of those concepts. But during the defense, you are asked questions, so the remember part is tested during the defense. Now we're going to look at each thesis type and see how those skills are presented or supposed to be in your thesis. We start with the author's software solution. The first part of a software solution thesis is usually the background part. And we will see in later videos that you shouldn't call your chapter background, but it is just that the thesis should start with some background knowledge so that the reader will understand where you are starting your work from. Usually the first part is some domain concepts. So for example, what is an RPG game? What are the elements of a game? What is a game mechanic? So all sorts of different concepts that are relevant for your work. And this shows that you're able to understand the domain. Of course, you're also teaching that domain now to the reader. Next is usually the market analysis. So what similar games exist? How are they similar or different from yours? So this shows that you're able to analyze the market. You're able to see that, well, some games work, some games do not. Why? What makes them different? What makes a game valuable? What makes a good RPG game? Or whatever software product you're making, you are able to analyze existing software products, see what is good in them, what is bad in them, and then use that result of the analysis for your particular product. Now, it is very important that you do not just write arbitrary stuff in this first part of your thesis. Your thesis as a whole needs to be connected and meaningful. So when you're teaching the reader what is a game mechanic, that knowledge of what is a game mechanic should become relevant in the subsequent chapters as well. So don't just copy some chapter of a textbook. So really focus on the terms and concepts that you are using, let's say, in your game design. So write about the concepts and the information that is also relevant in the subsequent parts of your thesis, and really connect your subsequent parts to this first part. From this first section, the reader should now understand the motivation. Why are you making what you're trying to make? What is the product you intend to make and why is it needed in the market? So this is basically your problem statement or your goal statement or your motivation. The reader should understand from the domain concepts and market analysis and your first part that, okay, so this is the problem that exists in the world. You have identified this problem, that there is no this particular video game out there, or these games are all boring and you want to make something exciting. Whatever the problem is, the reader should now know this. And with that in mind, they now proceed reading on how you solved or at least tried to solve that particular problem. Next comes the implementation part. So there you're showing that you are able to create new solutions in the domain of your choice. Now the implementation part can depend what is exactly in here. It depends on what was your problem and how did you approach this and what did you do to solve it. but usually it's some part design, maybe some game design or virtual reality design, or whatever the design was that was supposed to solve that problem that the reader understood from the first part of your thesis. Of course, you might have had some difficult technical challenges, so some architectural challenges, some algorithms you made, some technology descriptions. Those can be here as well, but mostly this part should be about how you solved that particular issue that was proposed in the first part. For an author software solution, this is basically the core of this thesis type. Now, you of course have your product itself, the application, so you can apply the knowledge and software development skills or game design skills that you have learned in our courses or during your studies. So the product, the software product itself, that is in the appendix. So you will include that application with your thesis, but it is not in the actual textual part of your thesis. It's a software solution, it's in the accompanying files later on. From that part of your thesis, the reader should now understand what is your product? What is the software you made? What was the design? How did you implement it? What challenges you faced? So basically they now know about your product. You can include screenshots. You can refer to the actual software in the accompanying files. You can refer to some videos that you made of your software. But basically the reader now understands what is your solution to the problem you proposed in the first half. So after the second half, they know your solution, and now they move on to the third part, which is testing. So this is evaluation. So you're going to evaluate your software product. How well did it work? Did the users enjoy it as much as you expected them to enjoy it? Or did it sell on the market? Did you have good retention of players? Different things that you can test depending on the problem and the solution you made. It can include performance testing, usability testing, bugs, all sorts of different testing, but you don't have to include every potential test you can imagine. Instead, you should know what was the problem, and now you're testing, did your solution solve that problem? If you try to make an enjoyable game, you should now measure, was your game enjoyable? If you try to make a game that runs smoothly on 10-year-old mobiles, well, you have to test on the different mobile phones, different platforms, and you need to do performance testing. So it really depends on what was the identified problem, your solution to it, and now you're testing your solution against the problem. And there's always room for improvement. So in the very end, you have to say how do you plan to improve your solution. Maybe you identified some issues that were left unsolved. So now you write that, look, the testing showed these 5 issues. These would be very good to solve, but unfortunately I will solve them later, or maybe some of those are something that you don't want to solve because they're not that critical. It depends, but you have to write about that as well. So this is the 3 parts of a software solution thesis. Now these are not the headings or titles of your thesis, but it's just the semantical parts that your thesis should cover. And they show the different layers of the Bloom's cognitive skills taxonomy. Next up, we're going to look at the contents of learning materials and also the user manual type theses, because these will be pretty similar. In both of those, you're making some guide or helpful materials that people will use to learn something or to solve some challenges that they face. The first part is, well, the background part. So who is this material for? Why are you grading it? What is the background of the users of your particular material? So basically the target audience. Next, of course, the target audience might already have some existing materials. So what similar materials exist? If you're writing a new Unreal Engine tutorial, well, there are plenty of different Unreal Engine tutorials already in the world. Why is yours different? Or why are those not suitable for solving a particular problem for your particular target audience? Or if you're talking about courses, then maybe there already are video game design courses, then why would you make a new one? Of course, you can then identify that the existing ones have some issues, and now you are trying to solve those issues. And it could also be the case that maybe those particular issues are already solved in other universities, so now you are bringing those solutions to an existing course over here, or you're making a new course, or whatever the case may be, you still need to investigate some existing solutions, existing materials, existing courses, existing guides, depending on what is it that you are particularly making in this type. At the end of this part, the reader should understand, well, your motivation, what is the problem you're solving. For example, maybe there isn't this particular course in the University of Tartu, so you're making it. Or maybe there isn't some good tutorial or good documentation for an API or library that is brand new. So there is a problem that your thesis is trying to solve, and from the first part, the reader should clearly understand what is the problem you are trying to solve, what materials are you trying to make, why are you trying to make them. The second part is, well, the implementation. So there you're applying the topmost cognitive skill, creation. So you're implementing some new materials. You have to, well, establish the learning outcomes. What are those materials supposed to achieve? And then the didactic methods you're using to make those materials. And of course, you should also describe the materials somewhat in that part of the thesis. Now, the actual materials you make, those are separate. So those will not be in the thesis, so those will be in the appendix. Regardless if they're videos or a PDF file or some website, those will be added in the appendix of your thesis. They could be in the accompanying files in appendix, not included in the actual document. But still, they should be included in the thesis, but they're separate things. From that middle part, now the reader should understand what materials you made. So your description, your explanation of the didactic methods you used, the learning outcomes, the materials we're supposed to achieve, all of that should give the reader a pretty good picture of what were the materials or a guide that you particularly made in your thesis. They might even go to the appendix or the accompanying files or a website and actually look at the materials, but your description should already give a pretty good idea. The last part is testing those materials. So you use these materials to teach a course, or you use that guide for your particular target audience, and you have to see and measure how well did these materials help your students to learn a particular topic, achieve particular learning outcomes, or if it's a guide, then how well did that guide help solve some particular challenges in the world for your particular target audience. You gather some feedback and you analyze that feedback. Of course, during the use of those materials or a guide, you might have developed some ideas that maybe these things didn't work quite well, or the student feedback tells you that they liked some of those and didn't like some other parts of the materials. So you have some sort of a discussion chapter or conclusions. So this isn't the conclusion of your entire thesis, this is the discussion chapter where you can now explore the ideas you got, analyze the feedback and your use of the particular learning materials. And overall, these are the three semantical parts of the learning materials type thesis or the user manual type thesis. Next up is the research type. So there, the first part is the background part, so the domain concepts. So there you show that you understand the domain and you also relay that understanding to the reader. And then you analyze the existing papers and algorithms. So what other similar algorithms exist, and you really analyze the pros and cons and what is missing in that field in those papers. From that first part, the reader should understand what is the problem or the goal you're trying to solve. What is your algorithm supposed to do? Now, it doesn't have to be an algorithm. It could be something else, like a game mechanic. So you have investigated different papers that, let's say, use game mechanics as an educational tool or in some other creative way. And now you are trying to see that, well, in those papers, the game mechanics are not working as well as they should. And now you're trying to create a new game mechanic, for example. But regardless of what it is, the reader should now know from the first part of your thesis that there is a problem. You have identified that problem from the existing papers and knowing the domain concepts, the domain background, and now you are trying to solve that issue with a new novel solution. In the second part, you have the synthesis of your solution. So this should really be a rigorous part. So I've just written here aspects 1 to n. So it depends on your solution. Maybe the solutions have different steps, and now you focus on each of those steps in depth. And this is showing the application of your topmost cognitive skill, the skill to create new solutions. So your algorithm consists of maybe some steps, or there are different aspects to analyze, and you explore those aspects in the synthesis part. It is basically the derivation of the different parts of your algorithm and some proofs or reasoning why should those particular solutions that you made work. As mentioned before, you can also have your demo implementation, your demo app. So this is optional, but it really, first of all, shows yourself that your algorithm works, but also it allows you to make different illustrations for your thesis. This demo app will be in the appendix. It's a separate thing. Maybe people will look at it, maybe not, but from your synthesis chapter, they should be able to clearly understand what choices did you make and why did you make such choices, and they should be able to implement your algorithm from the description you provided in your thesis. So by the end of this second part, the reader really should understand your algorithm. They must be able to implement it based on the pseudocode or equations or whatever you used that best described your solution. And the third part is evaluation. So where does your solution fall short, or how does it compare to the existing algorithms? So the existing papers or algorithms you looked at before. Now you can make a comparison that look, the existing algorithm provides this result, and then you can show that your algorithm provides a visually better result, or it could be a more performant result. Whatever it is, this is where you make that comparison. Of course, every algorithm has its shortcomings, so you should list your own shortcomings as well, and based on those, how to improve it in the future, or what are the potential avenues of improvement. So this is your future improvements. And in this particular type, because your demo app isn't a product, then now you can provide where in actual products could people use your solution. So maybe it's a novel pathfinding algorithm. So you say that different video game developers can now take the algorithm that you have written in your thesis and use it as a pathfinding algorithm in their games, or maybe in some other simulations or whatnot. So you should list your possible uses of your novel solution. And so these are the different semantical sections of the research type thesis. Next up is article review. You start similarly as with the previous type. You talk about the domain concepts, the knowledge, what knowledge is needed to understand the domain. Then the reviewed algorithm, that one paper. Of course, you can provide some other papers as well, but you should focus on this single paper. What is this algorithm about? How is it explained in that particular one article? And of course, you can then list that this one particular article has these shortcomings, and then based on that, the reader understands the problem you are trying to solve, the potential issues with the reviewed algorithm or paper. What could be better about the algorithm and the article? Then in the synthesis part, you are explicit about the issues, you describe them in detail and explain why they are issues, and you offer your improvements. Of course, during that, you also create a replicated demo and the improved demo. So you replicate the results of the original algorithm and you show that, look, with your improvements, the improved demo works better in some way. From that part, the reader now understands what the issues were, how you analyzed them, why they are really issues, and how you improved the original algorithm or the reviewed algorithm. The third part is evaluation, so you can do some comparative testing now. Did your improvements really produce better results? Maybe they produced visually better results, but the performance went down. So you might have pros and cons there, but this needs to be tested and compared against the original algorithm. You should also specify what were the issues that were left open. So you can never make a perfect algorithm that works in all the different cases. So what are the potential new avenues of research or new avenues where someone else can improve? And you can end with a discussion chapter where you explain now your ideas, how did these improvements work, what could potentially be something that cannot be improved with this approach, and so on. So these would be the different semantical parts of article review type thesis. Next up is survey. Now with the survey type, you again start with explaining the domain. So what is the domain you are going to survey? And also why are you surveying it? What are the problems in the domain that you're trying to find answers to? And then next you should talk about your survey methodology. So what is your sample, how you're going to pick the objects that you survey, and what are the exact parameters that you're surveying. So maybe if these are virtual reality headsets, maybe one of the parameters is how hot does the user feel when using them for a prolonged period of time. Of course, another parameter could be the price of a headset. And in both of those examples, of course, you should describe how you are surveying those parameters. Well, the price, where are you getting the price from? From the manufacturer's website or some retailer? Or if you're trying to measure how hot the player gets when using the headset, then are you going to ask them how hot did you get? Or are you going to somehow measure it objectively? So those are two different methodologies you can use. Regardless, now the reader should understand from the first part, what are you searching for? What are you looking? What is the goal? What is the problem that you're trying to find an answer to? Next up is the survey itself. So you can describe the things, the objects that you're surveying. If there's many of those objects, then of course it's unreasonable to list them all. So previously I said you could have more than 100 objects here. So describing those one by one is not going to be very reasonable. So instead you should describe some general patterns that you might have observed. For example, if you're doing a survey on different curricula, then you could describe that some curricula have a large core part, so a lot of mandatory courses, but maybe some have a thinner core part and more optional paths or modules that students can pick one from. Or maybe there's just a large section of elective courses. So in the end, there are differently organized curricula, and you can describe that in this part. Furthermore, you can now specify how you're measuring some parameters for each of those objects. So for example, if they're curricula, then maybe you are profiling them based on their contents. So how much math courses do they include, or how much game design courses do they include, or how much programming courses they include. So this can also be described here. After that part, the reader should understand the data that you have found. So those objects that you had, the data for each of them, and how is that data structured. The next part of this particular type is the results analysis. So the analysis of the survey data. You surveyed the objects, you described it before, so now what are the actual results? Maybe you created some models or some sort of a systematic classification based on the data, based on the survey results. Your analysis, your classification, your models, your statistics, your graphs, all of this should be here, and with it some conclusions that you make based on the analysis. So maybe if you have profiled some curricula, you're doing hierarchical clustering on it, and you can see that there are 3 different clusters, and those are, let's say, video game design curricula, the video game programming curricula, and video game art curricula that all have different profiles. So this analysis, this classification, this result, this is a large part of the survey type thesis. And that will provide the reader a clear overview of how are those different things in this area that you surveyed organized, and well, what is the landscape. After that part, the reader should be able to understand what do you actually conclude based on the survey results. So what did the results give? What new information did you find? And lastly, there can be some evaluation part, so discussion, your ideas based on the survey. So maybe you purposefully filtered out, let's say, curricula that are focusing on business, video game entrepreneurship. So you could say that these could be maybe included in a larger survey. Or maybe that you surveyed only the curricula that have English information available. So now the next step would be also to include other curricula that are in the native languages of the countries they're given in. So there are always limitations, and in the discussion chapter you can discuss those, or you can discuss some other ideas that you got based on the survey, the actual data you got, and maybe some interesting observations were made. This is the place to state them. So overall, these are the semantic parts of a survey type thesis. Lastly, the experiment type. So in the experiment type, the first semantic part starts with domain concepts. What is the domain about? If you're making experiments with virtual reality headsets, then what is virtual reality? What is a headset? what are the technical aspects of those, of course explain the relevant things. For example, if you're making experiments with virtual reality controllers, then you can explain that there are these 4 different main controller types. They all look different, they have different buttons, and this is relevant knowledge because you will be later experimenting with those. Of course, very importantly, you should state your problem. So what is the problem you are looking a solution for? So with experiments, we're always trying to find out some set of things or measured properties that work best for a particular goal. We're trying to find some new information. Oftentimes this is like what is the best technology. And this best is quite relative. For example, you could have experiments with different virtual reality experiences, and you're trying to find out which of those make the player most nauseous. So maybe you have a swirling environment, and one is swirling around the horizontal axis, another is swirling around the vertical axis. Maybe you have some colors that are swirling around. So you have 4 different settings. You put people in there, warn them that this is going to make you nauseous, and then you measure where do people get most nauseous in. So this would give some insight on what not to do in a virtual reality application design, for example. Regardless, from the first section, the reader should now understand what is the goal of your thesis, or what is the goal of your experiments. What are you trying to find out? What should the tech achieve? Then you do your experiments with those different chosen technologies. The different combinations can also be experimented with, and I've listed here experiments 1 to n, so depending on how many objects you have, and maybe you have 5 objects and you're doing 2 different types of experiments with them, so this section can be a bit more complicated, but regardless you can now describe what was your experiment setup, what was the rigorously controlled environment you did your experiments in, what was the flow of the experiments, and how you measured the data from the experiments. After that section, the reader should now understand you got some data, this is how you found that data, and that data will now give us some information. That information will be written in the next section of your thesis, so the overview of the results. So you take that data, you analyze it, you find some patterns in the data, you measure statistical differences. So maybe the users who were using your virtual reality headsets marked how hot did it get in the headset from 0 to 5, and then you can do statistical analysis to see if one headset was relatively more hot than another one, and if there's a statistical difference, you can show that in this part of the thesis. What are the pros and cons, the useful tables, graphs, all sorts of different ways that you now represent the results and the results of the analysis you do on the data as well. After that section, the reader understands the conclusions, the new information you found from the gathered data, and of course from the analysis. The last section of this type would be the evaluation. So how would now one choose some technology for a given situation? For example, if we are trying to find the headset that gives the most enjoyable experience with the least cost, so maybe now we have found that the cost really doesn't matter and you can basically buy the cheapest headset on the market. Or maybe we have found that the cheapest headset really isn't that enjoyable and there exists some sort of a sweet spot where the price to enjoyment ratio is the best. So that would be the headset to buy if we're trying to minimize our costs but maximize the enjoyment. Of course, there can also be a discussion chapter, so that would be your ideas based on the experiments, based on the data, based on the analysis. Perhaps you made some observations that because all of your test subjects were first-time virtual reality users, then these results are only applicable to first-time users. And they could be completely different results for people who play VR every day. So overall, these are the semantical parts of an experiment type thesis. The takeaway from this video is that the different types have different contents. Depending on the type you choose, you will do different things, you will write about different things, you will show the same cognitive skills in different ways in your thesis. But still, every type covers all of the skills. Well, except remember, We also saw that different types also have similar contents. So very often we started with the domain concepts and some sort of a market analysis or analysis of existing things. And then in some types we created some things and we tested them. In other types we started testing things and then focused on the analysis. And in the end we usually ended with some evaluation. So please look back on the type of your thesis and see that all the semantical sections will be covered in your own work.